Okay, continuing our study of the equilibrium constant in video 3.1.2, I want to show you kind of a neat trick here. So the value of the equilibrium constant is dependent on 1, the temperature, and 2, the balanced equation. So we're going to learn a cool trick through this example. So we're going to consider this reaction in which we're given the K. So we're given Kc already. It's 140 at 800 Kelvin. So let's just go ahead and write our equilibrium constant expression here. So remember, it's products over reactants, so Kc equals concentration of NH3, that's going to be squared, over N2, and that's just to the first power, so you don't need to write a 1 if you don't want, and then H2 to the third power. So that's our Kc. Products over reactants, they're all gases, so they were all included here. Okay, now write the equilibrium constant expression and find the value of it for each of the following equations. So we're going to call this Kc prime, or Kc1. And this is our first reaction, so let's just write that here. Kc prime equals, and then we're just going to write it like we did before. So N2 product, H2, there's 3 of them, over our reactant NH3, and there's 2 of them. Okay, so you'll notice here that this reaction is exactly the inverse, it's reverse, of this reaction. And so you'll also notice that the equilibrium constant expression is exactly reversed as well. What was on top is on bottom, what is on bottom is now on top here. So what we can do, actually, is if you reverse any reaction, the Kc here, so the Kc you're going to get here, is just the inverse of the original. So let me say that again. If you take the reverse of the reaction, your Kc, your new Kc for this reaction, is just the inverse of the original. So if you reverse a reaction, RxN is just an abbreviation for reaction, Kc is the inverse of the original reaction. So let me show you what I mean by that. So over here, I'm going to do some bookkeeping. So I'm just going to write relationship to original. So relationship to the original reaction, really. So this reaction is just reversed. Okay, so that means then that our new Kc is just Kc to the negative 1. Our Kc was equal to 140, so we would just make that equal to 140 to the negative 1. Plug that into your calculator, and you get 0.0071 as your new Kc prime. Okay, so let's take a look then what happens if you change anything else about the reaction. So this reaction here, well, this reaction, if you look at the relationship here, what do you think has changed about it to the original? Well, the whole reaction is just tripled. So you have now, instead of 1 N2, you have 3, 9H2 instead of 3. You have 6 NH3 instead of 2, so we've tripled. Everything is times 3. So the relationship is you've multiplied the whole reaction by 3. So we're going to write our next Kc for this reaction based here. So again, just products over reactants. Our product is NH3 to the 6th power of N2 cubed and H2 to the 9th power. And that's going to equal Kc cubed. So if the reaction is times 3 cube Kc. So if the reaction is times 2, you would square Kc. So again, our original Kc given here is 140. 140 cubed. Plug that in, and you get 2.7 times 10 to the 6th. That's your new Kc. Okay, I would like you to pause the video and try the last one. Alright, so hopefully you saw the relationship here. So the relationship of this one is the whole thing is reversed, so there's two things. So the first one is it is reversed, and the whole reaction is multiplied by 1/2. It's multiplied by 1/2. So we had 2 NH3s, now we just have 1. We had 1 N2, now we have half. We had 3, now we have 1.5, or 3/2. You can write it either way. So it's reversed and multiplied by 2. So Kc triple prime is going to be equal to our products over our reactants, so a product, first product, N2 to the 1/2 times H2 to the 3/2 over NH3 to the first power, so nothing. So our Kc then, if this was reversed, we would do the inverse and to the 1/2 power, because it's multiplied by 2. So we have Kc to the negative 1/2. So that's going to be 140 to the negative 1/2. Plugging that in, and your new Kc is 0.085. So that would be how you manipulate the equilibrium constant to figure out a different reaction that's related to the original without doing a whole bunch of math. Okay, your next example, we're going to consider these two reactions. We're given the Kcs for both. This reaction actually comes from a combination of these two reactions here. So we're going to use this combination of reactions to figure out the Kc for this reaction. So we don't know what this Kc is, and that's what we're trying to find. Okay, so let's write our equilibrium expression for both reactions. So this is reaction 1. This is reaction 2. And we're going to write our expressions for both. So Kc1 equals products over reactants. Now this is a solid, so we don't include that. So Kc1 then really is just products. So Ba2 plus times fluoride, and that's going to be squared. And this is going to be equal to our 1.84 times 10 to the negative 7. And I just copied that here, and that's at 298 K. Kc2 is our products of reactants, all aqueous here. So our products, H plus, F minus, over hydrofluoric acid. And those are all to the first power. And that's going to be equal to 7.2 times 10 to the negative 4. Okay, and now we're going to call this Kc3. We're going to try to find Kc3, and that's for this reaction here. So let's write the K expression for this reaction. We don't want to include that because that's a solid, so we can just ignore it. So our products here, so Kc3 equals our Ba, our barium ion, times hydrofluoric acid, 2 of them, so it's squared, over our hydrogen ions. And there's 2, so that's going to be squared. And so we don't know what this is. So what we need to do now is figure out how to combine these two reactions so we can cancel out anything we don't have here. So the combination of these two things looks just like this. So I'm going to do this in another color. So my first reaction, okay, I know my barium 2 plus is going to be in the numerator. It's going to be on the top. So I'm just going to rewrite this. So my Ba 2 plus times F minus squared. Okay, so I got my barium taken care of, but I have this fluoride here I don't know what to do with. And then my fluoride isn't in the numerator of this reaction, so I need to figure out how to get rid of it. So what did I do to this? I didn't do anything. I just rewrote it. I didn't manipulate anything. So this is just going to be Kc1. I'm going to multiply this times my other reaction. Okay, So the other reaction has HF in it, which I also need here, but HF is on the wrong side. Here it's on the denominator, here it's on the numerator. So I'm just going to take this whole reaction and I'm going to flip it. So I'm going to rewrite it flipped over here. So HF is going to be on top now, over H plus F minus. Okay, so another problem is I have two HFs, and I have two H pluses here. So I'm going to take this whole thing, and I'm going to square it. So whatever I do to one thing, I need to do to everything in the reaction. So I'm going to square everything. So that looks pretty good. So what did I do to this reaction? I flipped it, or well, reversed, and I squared it. So here I did this now because my fluoride squared is going to cancel my fluoride squared in the denominator over there. Now that I've done that, and I have everything where I want it to be, I have barium 2 plus in the numerator, hydrofluoric acid squared in the numerator, and I have my hydrogen ion squared in the denominator here. I have to do the exact same thing that I did to these reactions to their KCs. So here, I didn't do anything to it whatsoever. So the only thing I did was rewrite it. So I'm just going to rewrite it. My KC was equal to 1.4 times 10 to the negative 7. So just like I multiplied these, I'm also going to multiply my KCs. So 1.84 times 10 to the negative 7 times whatever I did here to my KC for this second reaction. So first I'm going to rewrite it. I have 7.2 times 10 to the negative 4. So 7.2 times 10 to the negative 4. And if you remember, when you reverse a reaction, what do you do to the KC? You're going to take the inverse. So to the negative, and I squared this, so I'm going to have to square that. So now I have my two KCs. Go ahead and pause this for a second, plug them into your calculator, and see if you can get the new KC. Okay, hopefully you plug that in and you got 0.35. So that would be your final answer. So you have this new reaction here, and you figured out its KC from manipulating the Ks of the other reactions that are related to it. So my KC equals 0.35, and that would be your answer for this problem. And of course that would be at 298 Kelvin, because that's the temperature that your original Ks were. Okay, that is it for lesson 3.1 and video 3.1.2.